Good day to all. In previous videos, we discussed about how do we utilize the engineering concepts for agriculture and also how do we conduct the project work likewise. Today, we discuss about role of mathematics and the geometry in mechanisms. Okay, myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. Here, what is mathematics? You know from your LKG, UKG standards itself. Okay. Now I tell you the new topic, which is constant arc with method. What is constant arc with method in geometry of mathematics? A constant arc with curve means the distance between parallel supporting lines is same in all directions. I can explain with the one example. Here you see the lower left corner, there is a black color arc available. That arc is placed in between two blue color lines. You can maintain the movement of this arc throughout the line, two lines, in between two lines. From this we won't go for change any dimensions with respect to arc and the line, so that we can maintain the constant arc width throughout the movement, which is known as constant arc width method. But the difficulty is, if you consider the right upper corner, there is spiral available. If I draw the dark black line between the arc means, I can maintain throughout the movement as a constant. Okay, here you can understand. Okay, from this diagram, you can move the dark line through the spiral to no change of length of that mold. I mean block line. Okay, so that uh, and then also you can see from lower right corner there is circle available and any other polygons also available. You can see here the constant arc width maintained throughout the circle. Okay, throughout the circle you can maintain the constant arc width, but in squares or triangles you can't. Which is the problem? For the reason the reflex. You know about Leonardo da Vinci. His students is reflex. Reflex creates the some constant orbit polygons for cleaning the square holes available with the ditch. Okay, that how he creates the constant orbit method. You know, here, the constant of its creator between the two lines, and he can rotate this triangle throughout the lines. Okay, what is the important is how can we draw these triangles in geometry methods? Now I see.
The unit triangle. The triangle has three corners with unit length. Okay. In that, I draw the circles, every corner as a center of the circles. Because triangle has three corners, from these corners I draw three circles. The radius of the circle is side length of the triangle. The unit length triangle I considered, so that radius of the circle is 1. Okay. So from three corners I can get three circles. After drawing these three circles, I trim out all the external circles from the triangular region. Okay, so that I can get only blue color region. I can get the triangle which is known as reflex triangle.
Okay, from this I can rotate the reflex triangle within the square as like this, so that I can move this shape constantly throughout the two parallel lines. Okay, and then how the triangle moves? What is this center path? Thus, this path is known as centroidal, because every particle moves inside a lamina means which is known as a centroidal, so that we can move this triangle inside the square with the aid of epicyclical motion with the aid of this centroidal path. Then how can we draw this centroidal path means we can see. I draw the square as like unit length. Okay, I maintain the corner. I can get the four corners. I put one corner as a center. I draw the ellipse with the minor axis and the major axis with the unit dimensions. In center there is elliptical interactions available. I remove and trim the other parts not required from the center part of this uh, reflex triangle, so that I trim all elements, other elements. Okay, from this I can get epicyclical shape. I mean, says elliptical shape inside the square, which has 402-degree circle rather than 360-degree circle, which is the required centroidal path for moving the reflex triangle inside the square. Okay, not only square, we can move the lens shape inside the triangular also. From this we can get the triangular shape movement to the aid of lens shape. Okay, here the lens shape can rotate the inside the triangular shape. From this we can calculate the path movement of the lens. Okay, so we can convert this movement with the aid of mathematics, so that the mathematical role in engineering is more important. Okay, then applications of these principles in engineering problems. What was the applications? I told about the lens shape and also reflexive triangles. Okay, we can convert each polygon into constant object method with different shapes. Okay, we can utilize the shape for engineering applications. Then one of the basic example I did with my master degree, the tool paths in pocket milling. Okay, here pocket milling is remove the workpiece material in the form of polygon shape on component face, as like this. Okay, first the end mill cutter is available, and I can get the square polygons with the aid of end mill cutter, which is known as pocket milling. For creating the empty space on the component face with the aid of different tool paths. Tool path means end mill cutter movement path. In engineering industries, they are replacing zig cut path, zigzag cut path, contour parallel path, and the curvilinear path. What is zigzag? That path may offset with uniform distance, which is known as zigzag. The tool moves over this zigzag path, and then finally we can get the empty volume on the component face, which is known as pocket milling. From these tool paths, zigzag tool path, we can achieve. Here also some problem available. For the reason engineer developed contour parallel path for increasing the productivity. What happens in contour parallel path means they offset the outer topology of the pocket. From this, they get the final shape of the empty pocket. Okay, from this, can they achieve the different tool paths for creating the pockets on component face. Okay, in that you see engineers Michael Baderman. He is the Russian scientist. He create further new tool path, which is known as curvilinear tool path, because the square toolpaths or contour parallel toolpaths has corner problems. I later tell you what is corner toolpath. So that the Michael Baterman introduces the curvilinear toolpath. From this, he controls the corner problems inside the polygons, but in most edge of the pocket, again the corner available, so that the problem not solved. So pocket milling is one of the important operations utilized in the manufacturing industries. Manufacture of pockets for regular solids other than circular cross section is difficult task in manufacturing, as what we are discussing with the tool parts in pocket milling. Okay, and then the problem. The every pocket milling has its own toolpath. Here, see the corner of the toolpath. What is the problem? Here, the circular part to end mill cutter applies for making a pocket. When it touches the corner, the circular toolpath can't enter it into the exact toolpath, so that I can't able to 90-degree corners. And also, the tool moves and the tool offsetted with each other. Two tool paths have its own straight lines. Okay, the distance between straight line or uniform, but in corners there should be a unmachined area. How can we avoid this unmachined area? Let's see. Okay, here I convert that reflex triangle into end mill cutter shape. Okay, I introduce the relief angle, drag angle, clearance angle with the reflex triangle. and then I can make a reflex tool profile. Okay, after that, and also I may create the centroidal path. Okay, already I told you how do we make the centroidal path. Okay, and then I offset the centroidal path with respect to the x-axis and the y-axis. From this, I can get the new tool path for making a empty volume on component face. From this part, the tool is moved, okay, in x and the y direction. From this, we can achieve the empty volume. Okay, the first method in that I utilize two methods. First, I make a tool profile, and then I make a epicyclical motion with that tool profile. First method deals with the design and the development of new tool, adapting the concept of motion of the particle inside the lamina, which gives planning for new tool path is also considered, and that approach identified as tool path approach. The epicyclical motion of the tool along the tool path is also taken into account and is referred as epicyclical motion approach, which is uh, conducted through gear train, elliptical gear train. We can achieve this for determining the tool profile for and tool path, which results in square particle length. So that for creating the uh, this kind of activity, we should create a new tool profile and a new gear train mechanism for achieving the epicyclical motion. So that two important steps are available. In and another example is also available, direct rotary motion not available from engines. So we can get from Mancall engine with this principle. Mancall scientist also utilizes this reflex triangle for making a rotary engine, because every engine, uh, due to the pressure volume increment, the reciprocating motion is converted it into circular motion. You know about piston and the cylinder movement. Inside of the cylinder, the piston moves reciprocate move. Piston makes a reciprocating motion inside the cylinder. From that reciprocating motion, the crankshaft, the crank pin may use the rotary motion. From that only the engine and the wheel are getting the rotary motion. But there are lot of power losses are available. For the reason, Mancall utilizes the reflex triangle as the piston. From this, we can get the direct rotary motion from the engine. Likewise, we may utilize the mathematics and the geometric concepts for newer tool profile and also newer mechanisms for engineering applications. So, students, you may try different polygon shapes, different polygons with the transit orbit method. You may create a new mechanism for different applications with the reduced power loss, so that you may try your projects with these kind of activity. Okay, thank you, students. Thank you all. If you have any doubts, you may ask me through comment box. Thank you.